Here we go. Chapter 8. We've said that the root word in rationals is ratio. And ratio, when you talk about a ratio, you talk about girls to boys would be 3 to 2, or whatever. And remember ratios, you can write it like that, or you wrote it like this, or you wrote it like this. You've written 3 algebra, probably, I don't know, so grade 3. And so this is the form that we think of when we think of rationals. Fractions. Fractions in general scare you. I understand that. These actually are not as scary. Well, I don't think they're as scary. If you know how to factor, these are not scary. Put it that way. But a lot of the same laws apply as they do with fractions with regular numbers in it. So let me show you what it is that you're thinking. So after each of the, or as we go through this whole process today, I'm going to show you what you did with regular fractions and equate it to how we're going to do this with polynomial fractions. Okay? All right. So when you read, what does this reduce to? A half. You know that, your brain knows that, you hop right to that. But what you didn't know or what you don't remember is the way you used to do that when you very first learned it, that was hard for you. And so what your teacher had you do at some point was to write all the factors of 12. 12 would be 2 times 2 times 3. And then you would write out all the factors of 24, which would be 2 times 2 times 2 times 3. You wrote up a prime factors of each of those. And then you said, okay, then you canceled out the common factors. So you went, this 2 cancels out this 2, this 2 cancels out this 2, this 3 cancels out this 3, and I'm left with 1/2. You have no idea that's what your brain's doing, but that's what it's doing. It's finding the common factors, cancel them out real fast, and seeing what you're left with. So that's the process that we're going to use when we have polynomial fractions. Before we start doing them there, though, I'm going to warn you about something we cannot do. Can I cancel these x's out? No, because these two things are not factors because of that plus sign. These are add-ins. They call them add-ins. A-D-D-E-N-S, add-ins. These two are factors. These are not. So let me show you. So I cannot cancel that. Now let's look at that with regular numbers. You know that 3 over 3 plus 1 is 3/4, right? Okay. Well, if I wrote it as 3 over 3 times 1, no, stick with this. If I were to try to cancel these 3's, I would not end up with 3/4, right? Because these two are added. However, if it was 3 over 3 times 1, we know that's 3 over 3, which is 1. And also, since all these are factors, if I cancel those common factors, I still get 1 over 1. So that's proof with just numbers that you know how this does not work. You can't cancel the 3's here, you can with those common factors. So you can cancel all factors, which is why we have to factor first today real quickly, just to get all this down. So let's start with our first one. Here's your first fraction. Meaning I've got a numerator and a denominator. So we're going to do that same process that you did in the 5th grade. We're going to write all the factors at the top number over all the factors at the bottom number. We're going to cancel out the ones they have in common. That's what it's all right? So let's do that. On the top, I think I can find factors of -15 that add up to -2. And it'd be a mini mark because there's nothing in front here. So I can go on and put x and x. What would those two factors be? -5 and +3. Beautiful. So these two factors, this times this, equal that trinomial. On the bottom, what is that? X squared minus 9. Difference of two squares. So I know its two factors are x plus 3 and x minus 3. So now I have factors on the top, I have factors on the bottom, and I'm going to cancel out any they have in common. Well, this x plus 3 and this x plus 3, common factors. And then what's left is x minus 5 over x minus 3. Can I cancel out those x's? No, because of the subtraction sign. Those are not factors anymore. See, passes is not hard. You just got to know how to factor. That's the key to the whole thing. All right, let's try another one. Our numerator is 2x squared plus 10x. Our denominator is 3x squared plus 16x plus 5. Okay, on the top, what is my GCF? What do you always do first? GCF, pull out a greatest common factor. I'm just looking at the numerator. So I can pull out a 2 and an x. And that will leave me with an x plus 5. How many factors did I end up with up there? Factors, I have 3. Got a 2 times an x plus 5. So if this bottom one has a 2 or an x or an x plus 5, I can cancel it out. All right, second, the denominator, that is not a mini mark. So I cannot set up 2 parentheses and put an x and an x. Cannot do that because of the leading coefficient right here. So instead, I need to do your WAC, do your box, do your MAC, do your AC method, do whatever method you do. I'm going to do mine up here, you do yours. We'll see what we come up with. I call it the AC method. Write down the A, write down the C. Factors of 15, X 16, 1. Almost there. So I do see a common factor as I switch. What's my common factor? That's gone. So my final answer will be 2x over 3x plus 1. Again, can I cancel the x? No. Do not cancel the x. I'm done. Again, not hard. But you gotta know how to factor. So you're up the creek without a paddle, as we say. Questions? I'm going to progress the complexity of them. All right. Now let's talk about how to multiply. How do you multiply rational expressions? Or let's go back to 5th grade, 6th grade, when you started multiplying regular fractions. So when you very first learned it, very first, learned how to multiply, you simply multiply the numerators, and 12 times 3 is 36, and 24 times 4 is who knows what. 16 carry the 1, what, 96? And then you reduce that to lowest terms. 6 would go into both of those, I think. 6 over 16, keep reducing to you do that. But when the numbers got kind of big like that, your teacher taught you some other tricks. But you can just multiply straight across. Or we could, remember the old not cross multiplying, cross canceling. And when I taught 7th grade, I called it the bow trick. I had kids draw a little bow like this, colored in, they love coloring in the bow. Isn't that cute? Because what the little boat reminds you is that you can cancel up and down. You can cancel across this way. You can cancel up and down. You can cancel across this way. And you all are really, I find that high school kids are really good about canceling diagonally, not too good about canceling up and down. You can do that too. Right? So I have got a jillion choices here, and I don't care which one you do, you're going to end up with the same thing I am. Just what do you want to start with? What do you want to cancel first? Okay, I hear 12 and 24. You want to start there? Okay, so 12 over 24, that's this line right here on your little bow. And that's going to reduce to what? 1/2. Okay. Is there anything else I can cancel? Looks pretty good. Can I cancel this 2 and this 4 on the bottom? No, because my bow does not have a line like that. You can't go across. You've got to stick with the bow. Now we'll go straight across. Numerator, 1 times 3 is 3. Denominator, 2 times 4 is 8. Is that what we got the first time? Okay. So concept, not hard. Not hard. But notice we got rid of common factors here, right? I looked at the 12 and the 24 and I said, what common factor do they have? 12, and I think about that common factor. So, if we have this problem, don't freak out. I've got numerator 8x cubed y over denominator 2xy squared times numerator 7x to the 4th y cubed over 4y. All right, so what we're going to do here is we're going to use the bow trick. We're going to go up and down and cancel what we can. We're going to go sideways and cancel what we can. We're going to go up and down, and we're going to go diagonal again. All right, so let's see what we can do. How about let's go up and down first again? I think most of you like that because when you see some on top of each other, it's easy to know how to reduce it. So we'll go with our 8 and 2 and turn that into a 4. Oh, wait a minute. Here's a common base of x. What did we do with those exponents when we divided? Subtract them. Very good. So 3 minus 1 would be 2. So I'm going to put x squared here. I've got a y and a y squared. Okay, now think this through, because 1 minus 2 is going to give me a -1. So where's that baby going to have to go? Downstairs, because he has a bad attitude. So he's going to go downstairs until his attitude becomes positive. All right, let's go up and down over here too. The only thing I have is 7 and 4 is not going to do anything, but the y's, I can cancel or subtract those exponents. Please remove the y squared upstairs and get out. All right, let's clean it up a little bit. I've got just across the numerator, I've got 4 times 7. No x's there, just this x to the 4. Oh, no, this is x squared here. So when I put this x squared and this x to the 4th together, what am I going to do to those exponents? Add them. Good. Got my x's, and then just left this y squared. Am I missing any? Hard to tell when you're standing up. When you're teaching like this, it's like, have you ever gone to Zoom and you're sitting on the front row, you can hear what feels like it is. It's going to feel like sometimes. All right, on the bottom, what do we got? We got a 4. And always put your number first as a coefficient. And then just a y, right? Am I done? No. One more, because these y's, you see there's no pluses or minuses in here anyway. It's all factors. So I can reduce it. So 2 minus 1 would be a positive 1, so he can go upstairs. Oh yeah, before the 28. Oh, so it looks like we just have 7x to the 6y. Is that what y'all are thinking? Yeah. And notice I put, when you have all factors, make sure to put your variables in alphabetical order. Don't put 7y x squared or x to the 6th in alphabetical order. I'm protocol for correction. So not scary, right? Okay. Let's try another one. 3x minus 3x squared over x squared plus 4x minus 5. Minus x squared plus x minus 20 over 3x. All right. Can I use the bow trick on this problem? I cannot use the bow trick because bows, whenever you have minuses or pluses, the bow trick does not work. Does not work. I can't go x here. Are you kidding me? I can't do that. So what am I going to have to do instead, do you think? Factor, factor. Yep, I got to turn all these adds and subtracts into a bunch of factors. All right, so here we go. I can pull 3x out of this top piece. Let's mark. First one, mark. There's a teacher that used to teach here, Mrs. Cole. She's been retired for 50 years, but whenever she did these, she would start, she said, and then we get to kill factors. Let's kill them. She'd go, okay, kill, x plus 5, x plus 5, wipe it out, x minus 1. Ooh, wait a minute. That's not x minus 1. I got too excited. I did get excited. So, what can we do to this to make it, can we make this an x minus 1? What if we were to pull a negative out of that? Then this would become a negative 1, and this would become a positive x. Now, is it an x minus 1?
Yeah.
It is. But I had to pull this. I had to pull this negative out, and that negative now is going to make the whole problem negative.
Wow.
Okay? Anything else I can kill? Yes! 3x. Yeah. Doesn't matter. Doesn't matter. This negative is just going to make the negative on the top. So on the top, I'm left with a negative x minus 4. And on the bottom, I don't have anything. So that's my answer.
Negative x minus 4.
Negative x minus 4. It could, I don't know, when you look at the answers in the book, I don't know if they distribute it or not. I will count it good anyway. All right, let's see what else we got. Some more killing. All right, x squared minus 3x minus 10 over x squared minus 3x minus 15. Oh, what am I going to do with that second thing? Put it over 1. Yeah, just like you put a whole number. It'll be quite a minute. Go off and factor on your own. That's all. Killing over there? You're what? You're getting bored? How can you get bored when you know you're reason to start killing?
Yeah.
It's math! You should be thinking this is so exciting. Alright. What can I kill? Boom, boom. Oh, what else? So, you let the boys. Now, your question might be, do I multiply that out? And honestly, let's look at a few in the back of the book before we start, because I don't know exactly what form the book wants. I would count it yes either way. So. All right. Now, the last one, division. Division. Now, let's go back to 6th grade. No, this is probably 7th grade. What is division? What did we have to do there? No, we don't skip it. That's not an option. Give me another option. Yes, sir. I called it same, change when I did 7th grade. We keep the first number the same, and then we change to multiplication, and we change or flip the second number. So, remember to do this? I'm here to see some light bulbs. 2/3. Change it to multiplication, flip the second number. Same, change. SCC. Now it's multiplication problem. We already know how to do that. We cross cancel. So the only difference between this and what we've been doing for the past 10 minutes is we're going to change before we start factoring and filling. I probably shouldn't. That's probably not a good analogy anymore in this day and age. That whole killing thing. You know, I used to be about that. I think that's funny, but it's not funny anymore. All right.
Well, the kids don't mind. I think it's mostly the teachers and executives. I mean, yeah, I agree.
All right, so here we go. We're going to leave the first one the same. I'm going to write it down the same. Change to multiplication, change or flip the second. Now I've got all factors. I can reduce away, cancel out all I want. No add-ins anywhere. And there's a lot of choices. Personally, I'm thinking I might just go across and put them all together first and then cancel at the end. Or you can cancel first and then, because I'm going to go 8, and then with my x's, I've got 2 here and 4 here, so that's a total of 6.
Whoa.
My y's, I have a y squared. My z's, I have 1 here and 1 here, so that's 2 z's. Now, you don't have to do it this way. And on the bottom, I've got a 10. I've got 2 x's. I've got a y. I've got a z cubed. And then I'll start canceling. But you do whatever order you want. We'll both end up in the same place. What else we got? Yay. You feel pretty confident?
Yeah.
Okay, you understand you got the AC or whatever this one, right?
Yeah.
That's the difference in 2 squares. This you're going to pull off 4, right? And then you're going to start, oh, wait, then we're going to say change. Okay, I trust you.
Okay.
Now, one more thing I need to show you, this thing called point discontinuity. 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 Is that it? Discontinuity, that's it. Point discontinuity. Not a big deal, but what does discontinue mean?
Stop.
To stop. That's right, it doesn't continue anymore. All right, if we had this equation right here, y equals x squared minus 16 over x plus 4, and we were asked to to graph it, simplify it and graph it. So the first thing I would do is to do factors, change that to x plus 4, x minus 4, the bottom is x minus 4, and then I would cancel out these x minus 4s. Well, the problem is, what can this x on the bottom never be? Yes, and why do you say negative 4? That's right. If you put a negative 4 in for x, you get a 0 in the denominator. Whoa, never, never. She does not like that. Remember the attitude, the denominator has a big attitude. One is you cannot have a 0 down there. So we have to say x can't be negative 4. X cannot equal negative 4 or we've got a problem, Houston. Because negative 4 plus 4 is 0. No. Right now I'm just canceling factors. I'm just looking at factors. I'm not setting anything to 0 right now. So what's left is, after I cancel that, I do have this x minus 4. That's just a y equals an x plus b. Slope of 1, y-intercept at negative 4. Y-intercept is negative 4. Slope of 1, I'm going to go down left or up, doesn't matter. So it's this line, but when I get to when I get to x is negative 4 right here, I literally have to do an open circle and then continue the line on the other side. Because I cannot put a negative 4 in there. I cannot let my x ever be a negative 4 or this will be undefined. Blow up the machine. And that's called a point help me out, Noah. Discontinuity. Thank you very much. Alright, so all you need to worry about then, because I'm going to be asking you where is the point of discontinuity, or sometimes these are called what is your x restriction. Let's see, why would that be a good word? Because restriction means you can't go there, right? You're restricted from something. So sometimes they'll say, what is your domain restrictions? Wait, domain, what is that? Well, that's my x's. So are there any x's that you can't put in this machine or break it? Yep, a negative 4 would break the machine. Okay? All right. Leave it on a little longer there.